Hello all, welcome to the next subtopic of electrostatics, and in this subtopic we are going to learn about electric flux. Now what is electric flux? Electric flux, it is denoted by a symbol phi. So this is what a symbol phi. This is the notation of electric flux. We are going to learn about the SI unit of electric flux, the definition of electric flux. So we have understood already that electric field it is nothing but number of lines of forces. Number of lines of forces per unit area. Number of lines of forces per unit area. Per unit area. So this area, suppose it is what ds. Okay, per unit area it is what ds. This number of lines of forces, it is called as electric flux. What it is called as electric flux. This is called as electric flux. Number of lines of forces are nothing but what? Electric flux. Okay. So let us talk about the definition of electric flux. The number of lines of forces per unit area. This is called as electric field. Okay. So this number of lines of forces are nothing but what? Electric flux. That means electric flux per unit area is called as electric field. Number of lines of forces are nothing but electric flux. So that means the electric flux per unit area is the intensity of electric field. Intensity of electric field, it is denoted by E. Okay. So let us consider the example. If suppose this is what a very small surface we take into consideration. This is a very small surface taken into consideration. Suppose the surface is what? ds. This surface is what? ds. What is ds bar? ds bar is the vector which is perpendicular to this area. So vector perpendicular to this area, it is what? ds bar. If suppose this is what an area, this is what a circle. So the area of a circle, we know it is what? Pi r square. Now area is a vector quantity. What is the direction of the area? The area direction, it is perpendicular to the surface. Area direction is always perpendicular to the surface. So this we can say this is what ds bar. Okay. So number of lines of forces. Number, it is what? It does not have any direction. Number is a pure number. That means it is a magnitude. Number means what? Magnitude. It does not have direction. So that means electric flux is a scalar quantity. Electric flux is a scalar quantity. Area is a vector quantity. Electric field is a vector quantity. That means scalar product will be there. Right? So if suppose I talk, this is what electric field denoted by E. E, it is nothing but number of lines of force. Number of lines of force divided by area per unit area. So suppose I talk about number of lines of forces. Number of lines of force, it is nothing but electric field multiplied by area. Electric field multiplied by area. What I told you, the number of lines of forces are nothing but electric flux. So this is electric flux. Electric flux, actually it is denoted by phi. So phi, it is equal to E multiplied by area. E multiplied by area. So this is what electric flux means. Now, if I want to write this in vector format, if I want to write this on vector format, so this phi, it is what? Number of lines of force, number is a magnitude, it is a scalar quantity, E is a vector quantity, A is the vector quantity, so I can write this as E bar dot ds bar, E bar dot ds bar, where ds is the small area which I take into consideration. Now, what is the formula of A bar dot B bar? The formula of A bar dot B bar is magnitude of A, magnitude of B multiplied by cos theta, right? So A B cos theta. This is what A bar dot B bar formula is, right? So that means what is the value of phi? Phi, it is equal to E bar E ds cos theta. What phi, it is equal to E ds cos theta. Okay, phi is a scalar quantity. So if I talk about, if suppose E bar and ds, they are perpendicular to each other, sorry, they are parallel to each other. So if E bar and ds bar are parallel to each other, if E bar it is parallel to ds bar, that means theta value it is equal to 0. That means what is the value of cos 0? Cos 0 it is what, 1. So we can say phi it is equal to A into ds. This is going to happen only when E bar it is parallel to ds bar. Now suppose I want to get SI unit of phi. So what is the SI unit of phi? SI unit of phi is going to be, what is the SI unit of E? Volt per meter. This is the practical unit of calculating electric field. Multiplied by ds. ds it is what? Measured in meter square. So volt per meter multiplied by meter square. ds is what? Area. So this is what, meter meter will get cancelled. And what is the SI unit? Volt meter. What is the SI unit? Volt meter. Okay. So SI unit of phi is volt meter. So I request you all to please pause the video and write these things. Now whatever I told you, this is for a very small area ds. Whatever I told you is for very small area ds. So if suppose I write d phi it is equal to E bar dot ds bar, E bar dot ds bar. So for a very small area ds, the electric flux it is what, very small d phi. But if suppose I want to get complete, so what I should do, if I want complete magnetic electric flux, so this is what phi, I have to integrate this with respect to phi. So this is equal to integration of E bar dot ds bar. And moreover, sometimes it is written as a closed integral. Sometimes it is written as closed integral. So what is the formula of phi? Phi it is equal to closed integral of E bar dot ds bar. E bar dot ds bar. Okay. So this is all about electric flux. In the next topic, we are going to learn the very important law called as Gauss law. Okay. Thank you so much all of you for paying attention. Goodbye.